Hello students, and welcome to the continuing video series on solving problems with right similar triangles. And we have kind of a challenging problem here because this time we're asked to solve for three different variables at the same time: z, y, and x. Okay? And so one of the nice tricks that we can apply is to forget about one of the variables for a minute. So just let's not worry about y at this point. You can see that this green line that I'm highlighting here, this is called y, but we can also think of it as 16 minus x, because this entire length is 16. This short length here, this length right here is x. So this green right here is going to be called 16 minus x. Okay, so we will solve for y later. Okay. Now we just deal with solve for x and z. Okay. And since there are two variables that we're trying to solve for, we're going to need two different equations. One equation is not going to be enough. So using the Pythagorean theorem on this triangle right here, using the Pythagorean theorem on this triangle alone, we can see that x squared plus z squared is equal to 14 squared. Excuse me. So that's something very useful that we're going to apply later. Now let's deal with the similar right triangles. Let me get this back into the focus here. So I'm going to name this triangle A, B, C, and this thing here, this point here, I'm going to call this point D. And what we're going to compare is the small one to the medium one in this case. The reason for that is because Z is shared between the two of them. So we're going to use the fact that triangle ADB, that's this one right here, is similar to triangle BDC. Okay. And I'm going over this a little bit quick. If you don't quite see how I was able to write this down quickly, look at the previous video and study it again on how I work with this one. I went a lot slower on the last one. So then now we can set up a system, a proportion. We're going to compare AD to BD. Okay, so this is the small, and this is the medium, and we're going to make that comparison. We're going to put the small values on top and the medium values on the bottom. So we're going to compare starting out with AD. AD, that's this length right here. Okay? So this is y, but we rewrote this as 16. Well, actually, let me write this first. I don't want to skip too many steps. So that's AD, which then compares to BD over here, equals, and we use BD as part of the medium one, but if you look at the picture, BD is also a side length of the small one. This right here is also a side length of the small one. So BD in the small one, actually I should rewrite this as DB, so it's a little bit easier for you to see. DB, part of the small one right here. Okay, so that matches up with DC here. Okay, so DC on the medium one. Then we do what we always do, which is add in some. I'm going to slide this over here. Add in the values. So let's see, AD is 16 minus x, which is really y. Okay, AD here is 16 minus x, but it's also y. I'm choosing to use x right now because we're going to solve for y later. Okay. BD, if you look on the picture, it's just z. DB over here is also z. And then DC in the picture is x. Okay. So multiply both sides by x. and multiply both sides by z, and we get z squared. Okay. So now I have two variables in this equation, x and z. In this case, z is being squared. The only way that I could solve this is if I use this equation that we started with before. So if we use this equation, we can get that z squared is equal to 14 squared minus x squared. And these are the two equations that we're going to use. Okay. And I'm going to use substitution in this case. Both of these are equal to z squared, so we can set them equal to each other. 14 squared minus x squared is equal to x times 16 minus x. Okay. On the right-hand side, we're going to distribute 16x minus x squared, 14 squared minus x squared, and the negative x squares, which is very convenient for us, cancel, and that leaves us with 14 squared is 196, and over here this is 16x. So that means x is equal to 196 over 16, or that works out to a perfect decimal of 12.25. Okay, so this problem is only partially done, but I think I've done the most difficult parts of this. I'm going to leave it to you for homework. So as your homework, solve for y and z. Solve for y and z. And also complete the last problem here, number 10. Read the directions carefully and complete that last problem on your own. Okay? Solve for y and z and number 10. And we'll talk about these results during class. And as always, ask for help if you need it. This material is difficult. It's supposed to be difficult. This is a challenge. Okay, but you got to keep working at it and ask for help whenever you need it. Thank you for watching. Have a wonderful day.